Good evening, everyone.
Good evening, ma'am.
Okay. How's the preparation going on?
Well, ma'am.
Okay. Okay. So today we have a revision session for week 9 and 10. So first of all, I will be revising 9 and 10, like the methods, like it's the method of estimations, right? So we will be just going through how to like the process of estimating the parameters. Then we will be solving some 5 questions. Fine.
Yes, ma'am.
Okay. So shall we start now? I hope many of you have joined. Okay. So in like in week 9 and 10, basically what we are doing the method of estimating. We are estimating the parameters. Okay. So there are different methods by which we can estimate the parameters. So the first method is anyone? What's the first method? Like okay,
Methods of movement.
method of movement. So the okay, so method of movement. What are the steps that we do in method of movements?
We find first expectation.
We find expectations, right? So
Yes.
first of all, we find expectation and make it equal to the sample mean,
Correct. Yes. We do
right?
that. Yes, we do that.
Which is equal to m1, you like we denoted. Okay. Then secondly, we have the
MLE. MLE.
MLE, right? So what
Maximum likelihood estimator.
maximum likelihood estimations? Okay. So in maximum likelihood estimations, what we do first of all, we find out the
First we,
likelihood.
yes, then we find the log of the likelihood.
Yeah. We
Then
find
we
out the
then we find the we find its derivative and equates to 0, like how we find the maximum or minimum
yeah.
of any
So first
function.
of all, correct. So we find out the likelihood function, we log it, we multiplied log both of the sides, then we find out the partial differentiation with respect to the parameter. Okay.
Hmm.
Okay. Then we equate this thing equal to
Equal to 0.
0. Then we find out the value of the parameter. Okay. So these are the methods of estimation, which is MOM and MLE, which is method of movement and maximum likelihood estimate. Okay. So these two methods are generally used when my parameter, let's suppose if my x1, x2 till xn are IID samples following some distributions with parameter, like, like it is following some distribution with parameter p. Okay. So this parameter p is actually what here? It's a constant value. Okay. It's not a variable. It's a constant value. Okay. So, so when my parameter p is a constant value, I estimate the value of the parameter with the help of MOM and MLE. These are the two methods. Fine. Is it fine?
Yes, ma'am.
Yes, yes.
Okay. Okay then. Then we have the third method, which is Bayesian estimation. Okay. What is a Bayesian estimation? Anyone?
We start with the posterior mean and
Yes.
posterior movement.
Ma'am, posterior is equal to likelihood into prior.
Posterior distribution is directly proportional to the likelihood
and
prior.
into prior. Okay. Okay. So when do we use this Bayesian estimation? We use Bayesian estimation when the parameter is a what?
Ma'am, variable.
Variable.
Yeah, it's a
Variable.
random variable which is following some distribution. Okay. So this if my random variable is following a distribution, that distribution is known as the prior distribution. Okay. Then likelihood is for the sample and posterior distribution. According to this distribution, what is my posterior distribution of the parameter? Then after finding out the distribution, what do we find out? The posterior
Distribution.
Mode and mean.
posterior mean. Okay, so we have two things. When my parameter are constant, we use MO and MLE. If my parameter is a random variable following some distribution, we use the Bayesian estimation. Fine?
Yes, ma'am.
Okay. Okay, then okay, let me just search for an example. Then we will come back to the question. Just a second.
Ma'am, when do we calculate the posterior mode?
Posterior mode, when we have a discrete thing, like if my parameter is following some discrete distribution or some kind of like that, then only we use the posterior mode. Okay.
Would you please explain that?
But ma'am, in one of the lectures, sir has explained for continuous too, like not explained, but written for continuous too.
See, they are saying, okay, we can find out the posterior mode for the continuous as well, but it will be difficult for us to calculate, right? So that's why mostly, see, there are two methods. Like if you remember, we can calculate the posterior mode and we can calculate the posterior mean, correct? These were the things, but which is the most like the perfect, let's say, what we can say, the preferred, which is the most preferred method. We actually use the posterior mean, not the posterior mode. Okay, so when you have to calculate the posterior mode, you will be given that my parameter is following some discrete distribution. Then only that it's like easy for you to calculate the posterior mode. Okay, but when it's a continuous distribution, it's really difficult. Like calculating the values, like solving the values, it's difficult. So that's why we prefer posterior mode for the posterior mean for the continuous distribution rather than mode. Okay.
Ma'am,
Okay, ma'am.
what is the formula for posterior mode? I think.
Posterior mode, in the sense, if you remember one example that we did, if my x1, x2, xn is following some distribution like Bernoulli, I guess, with parameter p, okay, and this p was this was also following some distribution. And just let me just check. So this P is also following some uniform distribution with parameter, let's suppose some numbers like 0.5 and 0.5. Okay. So these P, so now we will be taking some samples, right? Now, if you see here, my P, this P parameter is following a discrete distribution. Now, we would be finding out the mode, like posterior mode. So how we want to do that? We will be taking samples, right? So we have a sample. Let's suppose I have 1, 0, 1, 1, 0. Then you would be finding out the probability that if my p-value is 0.5 given the samples, according to the samples, what is the probability of p equals to 0.5? Then you will be calculating this value. Again, you will be calculating for p equals to 0.5, which is the second one, okay, with the samples, right? Then you will be calculating some value. So then you will, okay, let's change this values. This should be, let's suppose 0.7 and 0.3. So this is 0.7 and 0.3. So at so you will be getting some values here and you will be getting some values here. Now you will check like for which probability the values are greater. So if this value is greater than x, we say that p equals to 0.7. So this is how we do the posterior mode. So with the help of posterior mode, we are estimating the value of the parameter. Okay. And what is a posterior mean? Posterior mean in the sense we would be calculating the average. Okay. We, like weighted average in the sense for the probability p equals to 0.7 and for probability p equals to 0.3. So we'll be taking the average of both. Then we will be estimating the value of the parameter. Fine? Is it fine? Do you guys, understood?
Yes, ma'am.
Okay. So this is how we used to do the Bayesian estimation. Okay. So, so main thing is that you have to remember this formula, which is the posterior is proportional to the likelihood into prior. So you need to know how to calculate the likelihood. So how do you calculate the likelihood?
Ma'am, multiplication, whole multiplication.
Okay, so this will be the multiplication of the function. Okay, from where my xi will be going, my I will be going from 1 to n. Okay, so where n is what? N is the number of samples. If my number of sample is going from 1 to 3, so this will be written as product of I going from 1 to 3. Correct? So you have to remember these things. Okay, this is how you calculate the likelihood. Fine? Okay, so shall we proceed with some questions?
Yes, ma'am.
Okay, so you guys have a pen and paper with you?
Yes, ma'am.
Okay, so I need you to solve the questions and tell me the answers. Fine? Okay, so this is your first question. The question is, the probability mass function of a random variable x is given to be this. Okay, consider random sample this. Find the method of movement estimate for theta for the given sample. You calculate this and tell me the answer. Okay?
Is it 0.43?
0.43. What about others?
Yes, ma'am.
0.428.
Okay. So how, okay. What about others? Only two of them have solved the question.
So theta is coming to be 3 by 7, which is 0.43.
3 by 7, which is 0.43.
3 by 7.
Yes, ma'am.
Yeah. Okay, fine. That's good. Okay, so how did you solve this question? Can you tell me the steps?
First, I find the
Sample mean is 1.
Okay, just a second. Just a second. I'll just say the name of one. Okay, Shavani, you can.
okay. First, I found the expectation of this x.
Okay. How did you find the expectation?
0 into theta
Hmm.
plus 1 into 1 minus theta by 4 plus 2 into 1 minus theta by 4.
3 into
Sorry.
1 minus theta by 4.
Yes.
So this is how you calculate the expected value. So this expected value is coming out to be
7 minus 3 theta by 4.
7 minus
3 theta
3 theta by 4.
4.
Okay, fine. So this expectation value is coming this is the correct expectation for everyone? Yes or no?
Yes, ma'am, correct. This
Yes,
is
ma'am.
equal to 1.
Okay, fine. Now this is the expected value. Then the next step is we will be equating it with equal to what? The sample mean, correct?
Maybe 7 minus 7 theta.
Ma'am, 7 minus 7.
7 minus 7 theta.
Yes, ma'am.
So
Because
this
we
is
have
actually
6.
7 by 4, 1 minus theta, correct?
Yes, ma'am.
Okay. Now this expected value will be equated equal to what? The sample mean. Now what is my sample mean here?
1. 1.
1. Okay. So how did you calculate the sample mean? By adding all these value and dividing it by the number of samples, correct? So this is coming out to be 1. Now, this will be, now, we will put this equal to 1. So this will be 7 by 4. 1 minus theta equals to 1. Correct? Now, theta will be equal to what?
3 by 4.
This will be?
This will be 3 by 7.
3 by 7.
3 by
3 by
7.
7.
Okay. So, everyone sure? Like this will be 3 by 7? Someone is saying 3 by 4?
Yes, ma'am.
Yes, ma'am.
Okay, it's 3 by 7. Okay, so this is how you calculate the method of movements. Okay, so it's clear. Is this solution clear to everyone?
Yes, ma'am.
Okay.
Yes, ma'am.
Next, consider a random sample. This find the maximum likelihood estimate of theta for the given sample.
Where is the distribution of theta?
Maximum likelihood estimate of theta. The sample is given. This is the probabilities. There's no doubt
Okay,
the
same
probability.
question.
Yeah, same question, and you have to calculate with the help of maximum likelihood.
Sorry to interrupt. Can you, ma'am, can you just explain like why x bar is 1?
Okay, so what is my x bar here? Can you tell me?
Sample.
It's a sample.
expectation.
Okay,
Yes.
sample mean, right? My x
Okay.
bar is sample mean. Now, what are my sample here? These are my samples.
Yes.
Okay, so if I have to calculate the sample mean, that means I will be calculating the average. How do you calculate the average? I will be summing out all
Yes,
the values,
summation.
all the
Yeah.
values divided by
By
the number of
count.
count, right? So
Yeah.
in
Yeah.
total,
Okay.
I have 7 observation. If you sum this out, this will be coming out to be 7. Okay.
Okay, ma'am.
Yeah. Okay. So this is the probabilities, and these are my samples. Have you guys just note down the probabilities? Then I will just scroll it down.
Noted, ma'am.
Okay, fine. So these are my samples.
Can
Yeah.
you scroll a bit up so I'll just note it down.
Okay, fine. Just give me a thumbs up if everyone has noted down the probabilities. Then I'll just scroll it down. Okay, fine. So shall I scroll it down? Okay, fine. Now these are my samples. Calculate with the help of maximum likelihood.
Ma'am, is it 0.3?
Yeah. Okay. What about others?
The 0.3.
Yes, ma'am. 0.3.
0.3. Everyone has solved this question. Shall I do it now? Let's
Yes.
yeah. Let's see how we have done it. So okay. How did you guys solve this question? So first of all, we have to do it with the method of maximum likelihood. That means first I need to find out the likelihood function. What is my likelihood function?
Theta cube 1 minus theta by 4.
Okay,
whole to the
so
power
this
4.
is theta cube. Why it is theta cube? Basically, this is the probability that p equals probability for x equals to 0. Okay, and how many times 0 is repeating? 1, 2, and 3. Correct? Right? Similarly,
Yes, ma'am.
for x equals to 1, the probability is 1 minus theta by 4, and 1 is repeating how many times? 4 times. Okay. Then similarly, into the for x equals to 2, 3 into 1 minus theta by 4. And how many times 2 is repeating? It is repeating 3 times. Okay. So this is my likelihood function. Fine. Now, the second step is we would be taking out the log. So log of L would be what? 3 log of theta plus 4 into log of 1 minus theta minus log of 4. Can I write it like this? This thing? Everyone? Is this step clear?
Yes, ma'am.
This
Okay.
step
Then,
I'm getting doubt now.
Ma'am,
sorry?
can we take these constants out?
You have taken the constant down. So it would be like 1 by 4 raised to the power 7, correct? Yes.
And 3 raised to the power 3. That is that actually.
Oh,
has been-
sorry. So this will be 3 raised to the power. Oh, forgot that. So okay. So this will be like 3 raised to the power 3. Then we have the theta raised to the power 3. Then 1 minus theta raised to the power 4, and 1 minus theta raised to the power 3. So like this will be 7.
How do you get both the place divided by 4? 1 minus theta divided by 4.
Sorry. Once again.
The first one.
1 by 4.
Left side.
Which?
This is 1 minus theta divided by 4 whole square 4. Na?
Yeah.
That is a 4 value, sir. 4 1. And 1
Okay.
minus.
So this probability is what? For x equals to 1, correct?
Yes, correct. 4
Okay.
times.
4 times it's repeating. So that's why this probability into 4. Okay.
And 2 also 3 is there, no? But you given the divided by 4.
Huh?
The second one. Say x is equal to 2, correct? That is the 3
Correct.
times coming.
Yeah. So
But
it is multiplied 3 times. Yeah.
This divided by 4 is the constant, correct? The formula.
Correct. This is the whole probability, right? This is P1. This is P2. This is P3.
I got it.
Got it?
Yes.
Okay. So yeah, you can solve it like by taking out all the constants out and then taking the logs. You can do it as like that as well. Okay. Let me continue with this thing only. So this step is clear. This thing.
Clear.
Yeah. So now this can also be written as 3 log of 3 by 4 plus log of 1 minus theta. Okay, so I've just taken 3 by 4 as a constant term and 1 minus 3 as a different variable. So this I can write it like this as well. Correct?
Yes.
Yeah.
Ma'am, where did log theta go? Oh, sorry. Got it.
Okay.
Ma'am, I have written it like 3 times 1 minus log. 3 times 1 minus theta minus log 4. Is that also right? Okay. Yeah. Please continue. Yeah.
Then the next step is we would be partially differentiating with respect to what?
Theta.
With theta. Okay. Now the first, if we differentiate this would be coming out to be
3 by theta.
This will be 3 by theta. Then second, 4 into log 1 minus theta, right? So this will be what? 4 divided by 1 minus theta into minus 1. First I differentiated this, then I would be differentiating the inside value, correct?
Yes, ma'am.
The step is clear?
Clear.
Okay. Now 4 into minus log 4, this is the constant term, so I won't be differentiating it. It will be equal to 0 only, correct? Now, second, 3 into log 3 by 4, this is the constant term. Theta is not there, so this will be 0. Now, 3 into log 1 minus theta, it will be 3 divided by 1 minus theta into minus 1. Correct? Is this step clear?
Yes, ma'am.
Okay, fine. Now, so if you solve this, this will be 3 by theta minus 4, 1 minus theta minus 3 by 1 minus theta. Now, you will be putting this whole value equal to what? 0, correct? So let me take the LCM. So this will be 3 into 1 minus theta minus 4 theta minus 3 theta equals to 0. Is this step clear?
Yes, ma'am.
Okay. So if you solve this value, you will be getting theta as 0.3. Is this fine? Is the
Yes,
solution clear?
Clear.
Okay. So this is maximum likelihood estimate. So the main point is you should know how to calculate the likelihood function. Fine? Okay. Then next. Suppose X is following a uniform. Okay. Is this a discrete or a continuous distribution?
Continuous.
It's a continuous. Okay. Where theta is an unknown constant, consider a sample 4, 7, 8, 11, 5. Let theta MME. What is MME? MME is method of movements and ML is maximum likelihood. Okay. Be the method of movement estimator and the maximum likelihood estimator of theta respectively. Find theta MME minus theta ML. Okay. So that means first you have to find out the MME, the estimate with the help of MME. Then second you have to find out with the help of ML. Okay. Find this value and tell me the answer.
Ma'am, can you scroll up once? The last question answer alone.
I have to scroll up.
Yes.
Yeah. With this much?
With the log equation also. Yes, little down.
Where is stop? Now it's fine? You
Yes,
can
ma'am.
see the whole solution.
Yes, okay, ma'am. Thank you, ma'am.
Okay. Now, solve this question and tell me the answer.
Ma'am, can you make it a bit bigger?
Okay.
Ma'am, would you teach estimations, errors in estimations like bias, etc.?
Bias, that's like not coming in your answer. That's why. Okay, I'll just tell you the formulas for bias,
Like,
variance, and
is it not that much important to the end term exam? Like, I'm just asking.
No. That's why I didn't give you the questions for bias and variance.
Okay.
Ma'am, in week 10, sir explained about beta distribution.
Just raise your hand. Just raise your hand. Yeah, just raise your hand so that I can just call you. Yeah, Anupriti. Yeah,
Ma'am, in week 10, sir mentioned about beta distribution. So should we learn how it works? Like I wasn't able to understand how it's how we are finding posterior in that beta distribution and normal.
Okay, there is one question here. We will solve it and then I'll clear that up. Fine?
Okay,
yeah. Then you ask me the doubt. Okay, the second person who was saying something. One more person was speaking, right? Who was it?
Ma'am, I am asking here for maximum likelihood probability is 1 by theta, na? Because this is uniform.
Maximum likelihood one what?
I am asking this is uniform, na? So for calculating maximum likelihood, the probability should be 1 by theta, na? Because X is uniform.
You're just asking about the PDF, right?
Yes, ma'am. I'm also.
Yeah, this is 1 by theta. Yeah. Just carefully solve it and tell me the answer, okay?
And here the theta ml would be the minimum of this thing, right? So my answer would be is coming to be 3, 7 minus 4 actually.
Okay, what about others?
Ma'am, I have got theta MME would be 11.
Theta MM.
I also get the answer 3, but my MME is 14 and ML is 11.
Because MME rule is given that the highest of the given samples should be considered.
It's coming out to
That
the
is 11. MME is 14, I got.
Yeah, MME is 14. Vidrum, you have a doubt?
I'm getting 4.
Okay, yeah, I'll just solve it now. Okay, fine. So here what we have X is following a uniform distribution, right? Which is 0, 13. That means my PDF would be what? 1 by theta, where my values of X is going from 0 to theta, correct? So just remember that when in method of maximum likelihood, okay, if my the parameter is coming like in the let's suppose the values of X, okay, if it's coming out to be here, then what we do basically it will be equal to 0, x1, x2. I can write this as like this, correct? Yes or no?
Yes.
Yeah. So if I'm finding out with the method of MLE, so what is basically the likelihood function first? This will be product of I going from 1 to n, 1 by theta. I can write this as 1 by theta raised to the power n. Correct? So now, if I put this equal to 0, my, like I can't calculate or estimate the value of the parameter, right? So now what we're going to do, the thing is this likelihood should be maximum. So if my value of this likelihood should be maximum, that means this value should be minimum. Correct? Least value I have to take this. So if you see here in this range, if you see here, the least value of theta is basically my xn. Correct or not? This is the least value, like
xn or x1.
No, the least value, like the lower than the theta, which is xn. Correct?
Yes.
I have to take the least value of theta. So according to this, my least value of theta is coming out to be xn. Correct? Lower than theta. This is the value. Yes or no?
Yes,
ma'am. Yes, ma'am.
Okay. So that's why. So this theta n. So this xn is basically what? The maximum of all the sample. Yes?
No.
So that's why my parameter theta is basically what? The maximum of x1, x2, xn. Got the point? Yes or no?
Yes, ma'am.
Yes, ma'am.
No,
Okay.
ma'am, I have not understood.
Okay, which part? Which part?
See, 1 by theta to the power n is equal to 0. Then after that, what to do?
No, if you take the log and everything, you will be seeing that
minus log of something that is equal to 0. So that is e to the power, that is e itself. Now what to do?
So that's why, right? So my theta, I can't calculate the I can't estimate the value of theta with the help of log. Okay, so log, right? So what we're going to do, the thing is, the main important thing for maximum likelihood estimate is we have to maximize this likelihood function. Correct? That's the main important thing that we are doing in the question. Correct?
Yes.
The process, right? So if I have to make this value maximum, the denominator part should be the lowest, right?
Yes.
If my denominator part is smaller and smaller and smaller, my whole fraction value will be like larger, right? It will be maximum. Yes or no?
Yes.
Correct. Okay. Now, so now, if I have to make this value the least, I have to take the value of theta, which is the least value, right? So if you remember, if you see this, the least value, like which is lower than theta, it is basically xn. So if I take this value, which is the least value according to theta, if I put this value, my value, this fraction will be coming out to be the maximum.
Yes, so that is 4, no?
4?
Yes, if I divide something by 4, that will be larger than if I divide something by 11.
Isn't xn is the maximum value among all the x values?
This is the maximum among the all x values.
So if that is, if we put in place of theta, then our value will be less rather
it
than
will
more.
be the least in the instead of the most.
As per the sample, what he's saying, 4, 7, 8, 11, 5.
So if I
Three
take
is
4,
4 is 8.
4 is the best value I will take. That will make it the highest.
Why are you taking 4?
Because 4 is the lowest in the sample. If I divide it by 4,
no. See, you have to take this the value which is lower than theta. Theta is my value. So I have to take the value of theta which is less than this theta. So if xn is the least value according to theta, like just compare it with theta, which is the least value. If you see here, my xn is less than theta, correct?
It's a fine, right? So what he asking now? This what is given now.
Sorry, what? Can you repeat it once again?
Yes, ma'am.
Now you got the point. So the thing is, we are finding out, see, 1 by theta, and we have to maximize this value. If we have to maximize this value, we have to take the value of theta, which is the least. Okay. So here, if you see here, comparing to the theta, xn is the least value. So that's why we would be taking xn. And in the sample, xn is basically what? The maximum value. That's why my estimated value of theta is maximum of x1, x2 till xn. Is this fine? Emily is fine?
Yes, ma'am.
Okay. Then the next thing is, which is method of movements, which is the same thing. How do you calculate the method of movements? It will be, first of all, you will be calculating the expected value. What is your expected value?
1 by theta. 1 by theta into theta or 1?
It's coming to the theta.
Theta by 2.
Theta by 2, right? If my x is following uniform a comma b, what is the expectation? Expectation would be what?
Plus b by 2.
A by 2.
B plus a by 2, correct? This is the expected value. So according to the question, A is 0 and B is theta. So this will be what? Theta plus 0 by 2, which is theta by 2. Is this fine?
Yes.
Yeah. Now, I will be putting this value equal to what? The sample mean. What is my sample mean here? 4, 7, 8, 11, 5. So this is coming out to be what?
7.
It is coming out to be 7. That means my theta by 2 is equal to 7. So theta will be equal to what? 14. So according to the method of movements, my estimated value is 14. And according to MLE, what is my theta? Maximum of xn. What is the maximum value?
11.
It will be 11. So according to MLE, my parameter theta is equal to 11. And according to MOM, it is 14. So now I have to calculate the mod of theta MME minus theta MLE. Okay. So this value is coming out to be what?
3.
This is 14 minus 11, which is coming out to be 3. Now is it fine? Somebody was getting 4 as well. He was getting 4 as well.
Ma'am, I'm still confused why
Confused, ma'am.
11 is
Theta maximum 11.
One at a time, please. Same thing. Yeah, you just do.
Ma'am, can you explain ML part?
Which part?
ML part.
What I need to explain?
Here the maximum value is 11 and we take the theta 4. How did it come?
Maximum is 11 and we take theta 4.
Ma'am, in lectures it's clearly explained, ma'am. Could you, because it's a revision session, I'm sorry.
Let's say, okay. I'll just come back to this MLE part at last. Okay, after solving the 3 more questions, after that we will come back to this part. Is it fine?
Yes.
Okay, those who are not understood, we'll just come back to that. Okay. Okay. Let's solve the next question. Third question. We wish to estimate the probability P of getting the number 4 on a biased die using a Bayesian estimator. Consider 10 independent rows and let X be the number of times 4 appears on the die. Assume the prior distribution of P to be beta. The first thing is, out of 10 rows, if 4 appeared a total of 3 times, find the posterior distribution of P. Solve it and tell me the answer. The person who had a doubt in the beta thing, okay, just try to solve this, okay, and let me know what is your doubt. Fine?
Ma'am, the posterior follows beta 4 and 8.
Okay. What about others?
So it's coming out to be beta 4,8 because the likelihood is P cube 1 minus P to the 7.
What about others? Have you guys solved the question?
Yeah, beta 4,8.
4,8. Okay, everybody is getting 4,8. Beta 4,8. Anupriti, I guess, right? I put the name correct. Have you solved it?
Yes, ma'am.
Have you solved it?
No, ma'am, not here.
No? Okay. Now, the question is, we wish to estimate the probability P of getting the number of 4 on a biased die. So basically, what is my P? P is getting 4. The success of getting 4, correct? Yes or no? Right? Now, consider 10 independent rows and let X be the number of times 4 appears on the die. So basically, what is my X? X is the number of times my 4 is appearing on the die. Assume the prior distribution of P to be beta 1, 1. So P is following a distribution which is beta 1, 1, right? The first question is out of 10 rows. So in total, this is my N. Okay. If 4 appeared a total of 3 times, find the posterior distribution of P. So the first thing is, what is posterior distribution?
Likelihood into prior.
Into prior. Correct? So now, what is my likelihood here?
Ma'am, P to the power 3 into 1 minus P to the power 7.
1 minus P to the power 7. So how we got this? P is basically getting 4. So how many times I got 4? I got 3 times. Out of what? 10. So not getting 4 is basically 10 minus 3, which is 7. Now, what is my prior? Prior is P is following beta distribution. So for a beta distribution, what is my PDF? It is basically X raised to the power alpha minus 1.
1 minus X, beta minus
1. Okay. Now, so in place of X, my parameter, it is P, right? So P is following beta distribution. So this will be P raised to the power. What is my alpha? Alpha, it will be 1. So this will be 1 minus 1 and 1 minus P raised to the power 1 minus 1. Is this step clear, Anupriti?
Yes, ma'am.
Okay. Yeah. Now, this will be equal to what? P raised to the power 3 into 1 minus P raised to the power 7, because this will be equal to 0, and this will be 0, and something raised to the power 0 is 1. Is this step clear?
Yes, ma'am.
Okay, fine. Now, this is following what? Beta distribution with parameter what? Now, this will be equal to what? Alpha minus 1, right? So, if my alpha minus 1 is 3, so what is the value of alpha? Alpha will be 4. Yes?
Yes.
So this will be 4 and beta would be
8.
8. So this is my posterior distribution of P. Is this step, the solution clear to everyone?
Yes, ma'am.
Okay, fine. Now, the second thing is we have to calculate the posterior mean. How do you calculate the posterior mean of a beta distribution?
Alpha by alpha plus beta.
4 by 4 plus 8.
Basically, this is alpha upon alpha plus beta, correct? So this will be 4 upon 4 plus k. So which is 4 divided by 12, which is coming out to be 0.3, right? 0.32 something. Is it fine? Is the question clear to everyone?
Yes, ma'am.
Can I get a thumbs up from others as well?
Ma'am, can you explain the posterior likelihood part again? Like, I didn't understand how we are applying that whatever is given in beta.
One second, what?
Like for posterior likelihood into prior part, like how we are
Prior.
applying that. Prior, sorry.
How we are applying?
Ma'am.
Ma'am, please show the question once, just once.
Ma'am.
Yes.
Can I say something?
Yes.
Like people who don't understand, if you give another prior, like not 1 because if it is 1 it will be easy, because prior will be p to the power 0 1 minus p to the power 0. If prior will be 2 1 or 2 3, it will be easier to understand someone who don't understand how to get posterior.
How to get posterior? See, this is simple basic. Okay, this is the beta thing, right? So okay, we have one more question. Let's do that. And if then you don't understand, then I will explain it to you. Is it fine, Anukriti?
Yes, ma'am.
Okay, fine. Okay, so everybody has solved this question, right? Shall we move to the next question?
Yes, ma'am.
Yes,
okay, fine. Now, the number of accidents in a certain city is modeled by a Poisson lambda with parameter lambda. The observed number of accidents over a period of 10 days are this. Assume the prior distribution of lambda to be gamma 5, 1. Find the posterior distribution and the posterior. The same thing, just the distribution is different. Okay, solve this and just give me 2 minutes so that I can charge my laptop. Till then, we just solve it. Okay.
Is it gamma 3, 29?
Have you guys solved this question?
It to be gamma
33, 11.
32, 11. What about others?
33, 11.
Okay, Anukriti, are you able to solve this question?
No, ma'am.
Okay. Okay, let's solve this question. So the question is, the number of accidents in a certain is modeled by Poisson with parameter lambda. The observed number of accidents over a period of 10 days are this, and assume the prior distribution lambda to be gamma 5, 1. So we have been given lambda is following a distribution which is gamma 5, 1. For a gamma, what is the period? It is x raised to the power
4
alpha minus 1 e raised to the power minus beta
x.
Okay, so this is my distribution for gamma. Okay, so F5 is my alpha and 1 is my beta. Now, posterior distribution will be likelihood into prior. Now, what is my likelihood? It is following Poisson distribution, right? So, my likelihood would be what? It will be product of I going from 1 to 10 e raised to the power minus lambda lambda raised to the power x upon factorial x, correct? Now, this will be equal to what? E raised to the power n lambda, sorry, 10 lambda. Yes or no?
Yes, ma'am.
Okay. Now, this will be lambda raised to the power summation of xi, where I is going from 1 to 10, divided by product of factorial xi, correct? Yes or no? Is the likelihood thing clear to everyone?
Yes, ma'am.
Yes, ma'am.
Okay, fine. Now, this is my likelihood.
Explain the likelihood again.
Sorry?
Please, ma'am, explain the likelihood again.
Okay. Likelihood is what? The product of all this function, correct? So what I'm going to do, I'm going to put the values of xi here. So this is what my xi. Okay. So let's take one example, like the product is going from 1 to 3, let's suppose. Okay. So this is e raised to the power minus lambda, lambda raised to the power xi upon factorial xi. So if I'm taking the product, so this will be equal to what? E raised to the power minus lambda, lambda raised to the power x1 divided by factorial x1, correct? Now, e raised to the power minus, okay, so this is the product. So this is e raised to the power minus lambda, lambda raised to the power x2 upon factorial x2. Similarly, e raised to the power minus lambda, lambda raised to the power x3 upon factorial x3. So I can write this as e raised to the power minus 3 lambda, because e raised to the power minus lambda is repeating 3 times, so it will be minus 3 lambda into lambda raised to the power summation of xi divided by product of factorial xi. Can I write it?
Yes,
now is it clear?
I get it.
Yeah. Okay. So my likelihood would be what? So this is e raised to the power minus 10 lambda, lambda raised to the power summation of xi. Now I'm not writing out this value because this is like a constant value, right? It is not depending upon the parameter, right? So this is e raised to the power minus 10 lambda, lambda raised to the power summation of xi. Now what is my prior? Prior would be
gamma distribution.
Gamma distribution. So this would be what? So P lambda is like gamma. So this will be lambda raised to the power
alpha minus 1.
This is 5 minus 1, and e raised to the power minus beta is 1 into lambda. Is this step clear, Anukriti? Yes? Okay, fine. Now, this will be equal to lambda raised to the power summation of xi plus 4 and e raised to the power minus lambda
plus
10
5.
plus 1.
Plus 5, ma'am.
Plus 5?
Sigma xi plus 5. Because there is
lambda power is 4 minus 1. No, 4 only, no?
Oh, okay. Sorry.
4 only.
4 only.
Yeah, so this will be 4. Okay, now I can write this as what is summation of xi?
30.
Summation of samples.
Summation of samples.
That would be 30.
This is coming out to be 30 plus 4 e raised to the power minus 11 lambda. Now, this is lambda 34 plus 1 minus 1 e raised to the power minus 11 lambda. Now, this will be following what distribution?
Ma'am, I guess it should be 33
Gamma
in total.
30. Yeah.
33, 11.
Yes.
33, 11. Till here, is it fine to everyone?
Ma'am, above 1. This
yes.
Lambda power 34 plus 1 minus 1.
See, the gamma distribution is what? X raised to the power alpha minus 1. I just represented like in this form. So this 34 plus 1, this whole value will be equal to alpha and this is minus 1. Okay? Or you can write this like.
Ma'am, 33
Ma'am,
minus
how to
1.
write prior?
So this will be 34. Okay. Now what is my alpha minus 1? My alpha minus 1 is 34. So what will be my alpha?
It's 35.
34 minus 1.
So,
Ma'am, I think
x
the
to the power
summation
alpha
is
plus 1,
28.
right? X to the power alpha plus 1. It is.
No, actually, I got sigma xi to be 28.
Yeah, ma'am. Summation is 28.
Yeah.
I'm told 30.
28. I have not calculated it.
No, it's 28.
28. So my 28 plus 4 would be what? 32? right?
Yes, ma'am.
So now this 32 is equal to alpha minus 1. So my alpha would be what? 33. Now is it fine?
Yes, ma'am.
Okay. Now you got the point how we got gamma 33, 11. This solution is clear till here. Okay, fine. Let's proceed. Now, how do you calculate the posterior mean? What is the formula?
Alpha by beta.
Alpha beta divided by
33 by 11, which is coming out to be 3. Is the question clear to everyone?
Yes, ma'am.
Okay. Now you have any doubts in this, Anukriti?
No.
Okay. Yeah, this is the last question. A train running between two stations A and B will be late on any day by random amount X, where X is following uniform. Okay, this is the same thing. Assume theta is a non-parameter, find the maximum likelihood estimate. So what will be the maximum likelihood estimate of theta here? It would be
Max of x1, x2, xn.
Max xi.
It will be maximum xi. And what will be the posterior distribution here? Like my posterior will be proportional to what?
Likelihood into prior.
Yeah, so you calculate and tell me the value.
Ma'am.
Yes.
Ma'am, but where is prior?
Uniform 0 theta is given, right?
Ma'am, it will be like max of x1, x2, xn whole power n into 1 by theta.
How to calculate for likelihood here?
So, okay.
Ma'am,
just
where maximum likelihood is the maximum value of this x1 plus xn.
Just a second. This question is incomplete. So basically here my theta is following a uniform 0, 1. Okay. So this is my prior distribution. Now you calculate the posterior. Okay. This was an incomplete question. Where x is following the axis of frame is x. So this is why x is following some distribution. Now theta is following some distribution. Now you have to calculate the posterior. Okay. Okay, so first question is assume theta is a known parameter, find the maximum likelihood estimate. So according to MLE, what is the maximum likelihood estimate? My theta will be what? The maximum of
x1 to
x1, xn. Now, the second part is we have to calculate the posterior. Posterior is directly proportional to the likelihood into prior, correct? So now what is my likelihood function? It will be the product of I going from 1 to n, 1 by theta, correct? Into what is my prior? Prior is uniform 0, 1. So what is the PDF of 0, 1? It will be 1. So this will be equal to what? 1 by theta raised to the power whole n. Yes or no? So my posterior is directly proportional to 1 by theta raised to the power n. Is the question clear? This was the thing.
Yes.
Ma'am, in the question, it's not asked to find Bayesian estimate, right? Like, how did you frame posterior? Like, is it not printed over here or like?
Sorry, once again, what?
In the question, it's not asked to find Bayesian estimate, right?
No, basically this is the question. A train running between two stations A and B. This is the first. This is the paragraph. The first thing is you have to estimate with the help of maximum likelihood. Okay, this is the first question. The second question is they have given you that much theta. The prior distribution of theta is falling uniform 0,1. Then you have to calculate the posterior distribution. Posterior with the help of Bayesian estimation. I have not written the whole because
Okay. I understood. Yes, ma'am.
Yeah.
Got it.
So is this question clear?
How do you calculate prior?
Prior. Okay. So what is my prior? Prior is uniform 0,1. Correct. So for 0,1, the PDF would be what? PDF of a uniform is B minus
1 by 1 minus 0.
So this would be 1 minus 0, which is 1. Is it fine?
Ma'am, it was given 0 theta.
What?
That thing was given uniform 0 theta. No,
that is my x. Well, that is x. I'm talking about theta. My theta is falling uniform. So according for theta, my PDF would be what? 1 upon 1 minus 0?
Yes.
Yeah. So this will be 1. So prior distribution will be equal to 1. Is this fine now?
Ma'am, this 1 by theta whole power n, since it is a constant value, you are putting that n as power of n, is it? How you are putting 1 by theta whole power n, that product, how it becoming power here?
Okay. So I am taking out the product of 1 by theta, right? So that means 1 by theta for for I equals to 1, right?
Yeah.
Similarly, into 1 by theta for I equals to 2, into 1 by theta for I equals to 3. It will go on till 1 by theta raised to for n, right? So I can write this as 1 by theta raised to the power whole n.
Okay. Yeah.
Okay. So these were the questions. So is it clear, the questions and how to solve it? So basically you just have to remember the steps. Okay. So for the maximum likelihood, we have to calculate the likelihood and take the log. For the method of movement, you have to calculate the expectation and put it equal to the sample mean. And for the Bayesian estimation, you just have to remember this this equation. Fine.
Yes, ma'am.
Yes, ma'am.
Okay.
So basically, the posterior is also following uniform.
Posterior is also following a uniform distribution. Yeah.
But every time, if prior is uniform, not necessarily posterior will be uniform, right?
Not necessarily.
No, when we learn something, I cannot remember properly. If prior is normal, then posterior is normal. Like some points
conjugate something.
That's a conjugate prior, right? So we have to we have a conjugate prior in the sense if my x is following a beta distribution, my prior distribution will if my prior distribution is beta, then my posterior distribution is also coming out to be beta. If it's normal, then it's the posterior is also coming out to be normal.
So, but it is not follows the uniform, but because uniform is not a conjugate, right?
It's not
conjugate. Okay.
Okay. So can you guys tell me the beta distribution, the PDF of a beta distribution?
X to the power
alpha minus
1
minus 6 to the power
x.
beta minus 1.
Beta minus 1. What is the mean?
Alpha by alpha
plus
beta.
Okay. Then we have a gamma. Okay. Alpha comma beta. The PDF is
X raised to the power alpha minus 1 into e to the power minus beta x.
Beta x. And the mean is
Alpha by beta.
Alpha by beta.
Alpha by beta. So these are the two most important PDF that you have to remember. So basically, these all values will be coming up. The beta distribution or the gamma distribution. Okay.
Ma'am, we don't have to remember the variances, right?
No. And you will be given the formula sheet, right? So from that the variance is also
all PDFs and expectation will be given.
Everything will be given. The PDF, the expectation, the variance, everything will be given in that formula sheet. You don't have to worry about it. Okay.
Ma'am, could you explain about that normal thing? Like I exactly don't remember the formula. Like something like x bar into n sigma naught square.
Yeah, for the normal thing, now you just have to remember the you don't have to remember the whole step. You just have to remember the formula. For the if my posterior distribution is coming out to be normal, right, with some parameters mean comma sigma square, then you have to calculate the posterior mean. You just have to remember the formula. What is that formula? Let me just check. I don't remember it. Yeah. So it's basically x bar into n sigma naught square divided by n sigma naught square plus sigma square, okay, plus mu naught into sigma square divided by n sigma naught square
plus
sigma square. You just have to remember this formula, okay, and put all the values. You won't be asked to solve the whole questions, like you don't have to solve the posterior distribution. You just have to calculate the posterior mean, okay?
Okay.
Ma'am, for beta, sir also introduced many formulas, so I got confused which is the correct one and that can be used in most of the question. Like when beta and alpha is equal to 1, there was another formula like alpha minus 1 or no, alpha plus W by alpha plus beta and minus.
So that's just, he has taken the examples, right? You're talking about W, W, like he has taken W as the sum of the samples. So he has just denoted W as an equal to. So if you remember this, W is equals to x1 plus x2 till xn, correct? If you remember this thing. Yeah, so he has just denoted this whole. So I am just denoting x1 this equal to summation of x. I'm just writing it like this. So he's just denoting this value with the help of a variable, which is W. That's it.
Okay, ma'am.
Yeah. Just don't go through like the whole variable thing. You just have just solve step by step and denote it according to your convenience. So for my convenience, I can write this as summation of xi, right? So it's like easy for me to understand as well. So just write it down according to your convenience. Fine?
Yes, ma'am.
Is it fine? Yeah.
Madam, this earlier told the conjugate pairs. Could you please explain, madam? So, what situation that it will come, madam? Actually,
conjugate prior is the prior in the sense that if my prior is following some distribution, then my posterior is coming out to be that same distribution. If my prior is beta, my posterior is coming out to be beta as well. If my prior is normal, my posterior is also coming out to be normal. So that is a conjugate prior.
So only the beta and normal only it will come like that, or
yeah, normally beta. So for the gamma as well. So if you see this example as well, so my prior was what? So gamma distribution, right?
Yeah.
And my prior was gamma distribution and my posterior was also coming out to be gamma. So this is also a conjugate form. Okay. So the thing is, if my prior distribution and the posterior are coming out to be same, then that's a conjugate form. Okay.
Okay.
Yeah.
Ma'am, are you done with the questions?
Yeah, done with the questions.
So,
You
is
want
the
to
session
read?
completed, ma'am?
Yeah, it's fine. Yeah, it's done.
Okay, thank you, ma'am. Is this the last session, like for you?
We have one more, right?
Tomorrow, 11 at 12 will be there.
So I had only 5 questions because you have to do the same method in every question, right? Or the same steps.
So in normal, the formula is of mean, na? But if the question was finding the posterior distribution,
no, you won't be asked.
Okay.
Ma'am, in the last sum, ma'am, the first part, can you please explain it one more time?
Which one?
The last question, the 5th question, part 1. Yeah, yes, ma'am. Yes, ma'am. The first part, ma'am. Maximum likelihood estimate.
Maximum likelihood estimate. So how do you calculate the maximum? Basically, you just have to remember if my theta, that the parameter is coming out to be in the range of x. So if you see my x is following uniform 0, theta, right?
Yes, ma'am.
So my fx is what? 1 by theta, right? And my value of x is going from 0 to theta, correct? So my x value, my theta is coming in the range of x. So if I have something kind of like this, my MLE would be what? MLE for theta. So MLE for theta would be equal to maximum of x1 till xn. Okay. Let me take a general thing. If my x is following uniform a comma b, correct? So now my fx would be what? 1 by b minus a, right?
Yes.
Now here my value of x is going from a to b. So my if a and b are both like the parameters that I have to find out, I have to estimate. Now, if you see here, my in the range also my parameters are coming, right? Now the MLE would be what? For A, it will be the minimum of x1 to xn, and for B, it will be the maximum. How? If you see here, so if my likelihood would be what? 1 upon B minus A raised to the power n, correct?
Yes,
so I need to maximize this whole value, correct? If I have to maximize this value, I have to take the this which should be the least, correct? Okay. Now, how can I make this least? I can make this least if my B is small and A is large, right?
Okay.
Yeah. So how this will be the least? If you see here, if I write this as A, x1, x2, xn less than B. So with compared to the B, which is the least value xn compared to B, this is the least value. Yes or no?
Yes,
yeah. So this will be what? So xn. Now what is xn? Xn basically, if you see with the help of the sample, xn is coming out to be the maximum value, right? In the samples.
Yes.
So that's why my B is coming out to the maximum of xn. Now what is my A? E should be the maximum value, right? So my larger than A is coming out to be x1, right?
Okay.
Yeah. So that's my, and according to the sample, my x1 is the minimum value. Yeah. So that's why my A would be equal to minimum of x1 to xn. Now is it fine?
Yeah.
So say, yeah. So here in case of A, I had 0, and in case of B, I had theta. So now I need to find out the value of theta. So this is theta. So theta, the estimated value of theta would be maximum of x1 till xn.
Which is xn. Okay.
Fine?
Yeah.
No, Bob, actually,
x1 is also less than B, na? Then why not x1 is the, why can't we
This
put
is
x1?
okay. So this is a part of like, see, this is an order. So this is following some order. So we have to go by the order as well. Okay. So my x1 is less than x2 is less than xn. Now xn is less than b. So we have to take the smallest value with regard to b. The smallest in the sense which is coming next, like next smallest from b. So b is like xn, right? So we have to take that value as well. Similarly for A,
just a smaller than B, na?
Smaller than B, yes. Okay. Now I guess this is fine.
And for A, we find just greater than A.
Greater than. Yes, Shani.
I was going through the week 9 actually from morning. I have really problem of understanding that bias and mean squared error. Like I understand some easy problem, but when like there was a problem, theta was 2x bar. Okay, and x1, x2, xn, there are IID samples from uniform 0 theta. So find the mean squared error for theta hat. Like this kind of question, will it become in exam or I will skip
bias, bias means that this is not coming.
Okay, thank you, ma'am, because it's so confusing. I don't know why.
Yeah.
Okay, thank you. So class will be for 1 hour only?
Yeah, because the questions are completed. So
okay,
so I can
it's written 6 to 8 only.
Yeah, 6 to 8, because the thing is, like, I have just limited question, because in every question you have to do the same thing only.
Yeah, understood.
So if I just go with the questions, I have a lot of questions, but the methods are same. So it's no point is there, right? Solving again and again with the same thing. Yeah. The main point is, are you clear with the steps? How to do it, how to calculate the likelihood and everything. The main point is that.
So we can go through PYQs.
You can go through PYQs, yeah. You can solve the graded assignments. If you have solved the graded assignments, the practice assignment, that's enough.
Yes, we have solved.
Yeah. So my main point is, everyone is clear with the steps, how to calculate it, how to do the question. That's my main point. Have you guys understood everything?
Ma'am, could you just explain that MLE part for that 1 by B minus A again? Because maximum likelihood, like we wanted to maximize 1 by B minus A power n, right? So in that case, if you want to do that, then B minus A power n should be minimized, right?
Okay.
So when that will be minimized, like when the difference between them should be like, if it is
so if my B value is less and A is greater, it will be negative, some kind of negative, right? Like
Yeah.
it will be coming out like this will be so. How can I make a number b minus a smaller if this value is small and this value is bigger than b?
No,
Correct?
like if x1, x2, xn is in sorted order, then taking the difference of x2 and x1 will make it that difference smaller, right?
No, we have to take according to b and according to a only, right?
Okay.
Yeah, with respect to b and with respect to a only we have to see, not according to this whole sample. Okay.
Oh, okay.
Yeah. So we have to take according to b. So according to b, which is so we have to take the value of b which is less, right? So according to b, like less than b, which is coming out to be xn, right? In the order, if we see the value of xn is less than b, like it's how do you call it? Like next to b, right?
Okay.
It is xn. So that's why we have taken xn. Now, what is xn? Now, xn is basically according to the sample is the maximum value, right?
Yeah.
On the basis of sample. I'm not taking this the value of b according to the whole sample. No, I am telling you first of all you choose what is b, then according to the sample what is xn. Xn is the basically maximum value of that.
Okay.
Similarly, a is greater than x1, right? So and according to the sample x1 is the smallest one, the minimum value.
Okay. Okay.
Yeah, that's it. That's the point.
Yes, ma'am. And one other doubt in that mean calculation, like we will be like posterior means of two discrete variable we are calculating, right? Like probability of p given s is equal to probability of s given p into probability of p. For the denominator is probability of s, right? Like how do we calculate the denominator part?
The denominator part. Okay.
Because probability of s given p will be simply like finding the probability of sample using p, and probability of p will be given.
So probability of s would be what? The probability of p equals to some value, right? If it's like 0.7 into probability of p equals to 0.7 given s, right?
S given.
Sorry, s given.
Oh, okay, okay. Now I got it. Like it's total probability.
Total probability. If you remember this probability of, if I have to calculate probability of E, this was what? Probability of A into probability of E given A.
Given A, yes, ma'am. Like
Plus probability of B into probability of E given B. This is the same thing.
Right.
Anukriti, yeah.
Ma'am, can you show the question 3 again?
Question 3.
Yes, ma'am. In the prior part, it should be 0. Then why you like I didn't understood the calculation here.
So this will be what? P raised to the power 0 into 1 minus p raised to the power 0?
Yes, ma'am.
And something raised to the power 0 is what?
1. Okay,
1.
okay. Yes, ma'am.
Got it?
Yes, ma'am.
Ma'am, please show the question 3 once. Just I want to see it.
Yes. Okay, let's see the question.
Ma'am, tomorrow's session will be taken by you only.
Tomorrow's session, yes.
Okay.
Ma'am, what are these some important topics to cover from week 7 and 8?
7 and 8. IIT sample, right? Yeah, you have to remember the moment generating function, the central limit theorem. It's simple, right? There is nothing. There are only few topics. So like there is no specific thing. The first thing you have to remember what the IID thing, the central limit theorem, the moment generating function. Yeah. The main point.
Actually, I was not able to complete week 7 and 8 for quiz 2. That's why I was asking.
Okay. 7 and 8 are a bit easy topic, I guess, because you just have to remember the central limit theorem. What is a MGF? Like from the MGF, how can you calculate the PMF? And using the central limit theorem, you have to calculate the values and all. So, yeah. And some IID samples. IID samples in week 7, you just need to know what are IID samples. And if you have been given the IID samples, how to then calculate the expectations or the variance or something kind of like that. Just go through there will be a lecture, right? I guess
Yes,
revision
ma'am.
session or something. Just go through that, or just go through the slides as well. You will get an idea.
Yes, ma'am.
Ma'am, before one person asked you that the mean square error, the extra activity in week 9, you were saying that from exam point of view, you won't be getting questions from that extra activity, that the additional content questions, right, ma'am?
Yes.
Okay.
Okay, so I just wanted to ask, is the thing clear how to calculate every step and everything? Like, I just need to know. Is it fine to everyone?
Yes, ma'am.
Yeah, can I get a thumbs up? Okay. Okay, then that's good. Yeah, because I had only 2 questions, so I was not sure whether. Okay, then it's fine.
Ma'am, is additional content also important?
Oh. No, it's not important. Yeah, Shawni, yeah, what is it?
Can I ask a question from week 9 practice assignment?
Week 9 practice assignment. Yeah, sure. Tell me.
Yeah, I am sending it in a message also. And question was like that: x1, x2, x3 follows IID normal mu sigma square.
Can you just tell me the question number? I just see it.
Okay, and I posted in a message also. If you can see, I think this is practice assignment number 6.
Number 6. Let x1, x2, x3.
I know you did this thing in class, but currently I cannot do it.
Last time, likely estimate of sigma square. Okay. So, do you want me to solve this thing, right?
Is 0 I got.
Sample mean you have got. X1, x2, IID samples, given a random sample, they find the maximum sigma square. So the PDF is 1 upon under root 3 sigma e raised to the power minus x minus mu divided by 2 sigma whole square. Okay. So the likelihood would be what? The product of I going from 1 to 3, 1 upon under root 2 sigma, 2 pi sigma e raised to the power minus x I minus mu upon 2 sigma whole square. Now, are we putting out the value? So this will be, so this is under root 2 pi sigma e raised to the power minus. The first value is minus 1, so this will be minus 1 minus mu upon 2 sigma whole square into 1 upon under root 2 pi sigma e raised to the power minus, so this will be minus mu upon 2 sigma whole square, then into, this will be 1 by under root 2 pi sigma e raised to the power minus 1 minus mu upon 2 sigma whole square, correct? Okay. So this
I actually take out that 1 by 2 root 2 pi into sigma
as 3.
Then I did that summation e to the power summation of x minus mu whole square by 2 sigma square. Then I don't know what happened in my calculation.
So e raised to the power minus x. Okay. minus sine cos. 2 plus cos whole square divided by, so this will be 1 now. So 1 by 2 sigma square into e raised to the power minus 4 divided by 2 sigma square into e raised to the power just 1. So this is my likelihood. Then we will be taking the log. So log will be 2 log of 1 by 1 sigma plus, so this will be plus 1 upon sigma square minus 4 divided by 2 sigma square minus 1 minus 2. So this is my log. Now you have to find out for the
I can do that. After that, we have to partial derivative this with respect to sigma square.
So this will be log L divided by sigma square, right?
Mm-hmm.
So this will be the common term. Sigma square minus so we will be calculating, like we will be differentiating these values.
Okay, ma'am, I can try that.
Let me just see.
Thank you. I actually did it like that. E to the power minus, I just sum all the thing. That makes very difficult to calculating. It will be easier if I write them separately. Like you did, it is easier to calculate.
Yeah.
What I did, it is very difficult to.
How did you calculate? How did you calculate?
Actually, the first line of this page you wrote now, like that e to the power sigma plus 1 by 2 sigma, sorry, mu plus 1 to whole square, and I just add all the thing top, like e to the power minus summation of x minus mu square by 2 sigma square. I write it like that. Then I wrote e to the power minus 1 by 2 sigma square. I take that common. In bracket there is 1 minus mu 1 minus 1, like that. The thing you wrote, the same thing, I just wrote everything on 1e. That after taking log, it will be very difficult and very complex. Okay, I will do it by your method.
Yeah, you just have to do it like this only.
Mm-hmm.
Solve it right now.
Got it.
Yeah. Okay, then. So that's it. Shall we end the meet now? Is it fine? Shall we end the meet now? If there are no more doubts? Yes or no? Okay, fine. Okay, so thank you, everyone.
Thank you, ma'am.
Thank you, ma'am.
Bye, everyone. Have a great night. Let's go through the lectures once again, solve some questions, then it will be fine. Okay?
Okay, ma'am.
Yeah. Thank you, everyone.